Okay, folks, Physics 15, let's do a summary of everything that we've learned, specifically the equations we're going to be using, right? So velocity is equal to distance over time, right? And likewise, if you know the velocity and the distance, you can solve for time, right? If you know if you know the velocity and time, you can solve for distance, right? So all of those go hand in hand, okay? Acceleration is equal to the change in velocity over the period of time that you're measuring. That's going to give you your acceleration, okay? Likewise, your velocity, your change in velocity is equal to acceleration times t. So no big mystery there. So right, we've seen this. So that's all that is. It's just algebra. So now, if you have, say you want to figure out the velocity, say a car is already moving, and then it accelerates a bit for a period of time, and then you want to figure out the final velocity from that, right? So your V final is going to be equal to your initial velocity, whatever that was, plus your acceleration times t. Well, this is just this, right? So it's just a velocity plus another velocity. Yeah, don't get my t's mixed up with my plus. Okay. Okay. So not a big deal. That's an F, velocity final, right? Now your average velocity, if your average velocity, you know, over a period of time during uniform acceleration starting from 0, okay? So your average velocity, this is for uniform acceleration, right? That's what we're talking about. So your average would be 1/2 of your velocity. If you accelerated a car very uniformly, and it just went from 0 and accelerated up to some final velocity, well, the average velocity for that time is going to be the midpoint, right? Okay, so not a problem. But now, likewise, it's equal to 1/2 AT. Well, it's no different than this AT or than this AT, okay? So these, there's no mystery to this equation, okay? It's just V. V is equal to AT, so that's all that is. Now, distance. Okay, so distance, we know from up here, distance would just be your velocity time. That would just be doing the algebra, multiply both sides by t, and distance would be velocity times time up here, right? So distance, let me move this up, make sure you can see it. Distance is going to be equal to your average velocity times time, which is equal to 1/2 AT. Well, that's just right here. It's velocity times time. So distance is equal to 1/2 AT squared. So when you see all these different equations, don't be scared. They all just build on each other, okay? I'm going to do one more. Here's what we have so far. You saw how I did this. So I just started from basic velocity, or basic velocity, and went on. Okay, now we're going to do one last one. If you're already moving, distance equals V0 times t plus 1/2 acceleration times your time squared. Well, that's this. So everything just built. So we're just substituting everything for each other. Whatever something is equal to, we can just substitute that, but that helps us. So here, if you're already moving, if your vehicle is already moving, this one's a plus. So that's a V0t plus 1/2 at squared, and that will be for distance. Just add those two pieces, because that's a distance, velocity times time, and is a distance plus another distance gives you a total distance. Okay, so those are all the equations that you need for this chapter, and they all just build on each other. You're just substituting all the values that it can be into different equations, and it helps you depending on what parameters you already know. Okay, there you go.